Hello everyone. Today we will study combinations. First of all, let me introduce what is a combination. A combination is a collection of objects. And the order of objects doesn't matter in the collection. Order doesn't matter means in a collection, the set AB and the set BA, they are exactly the same. In a collection, AB and BA is exactly the same. We only care what's inside. We don't care which object comes first. We only care what's in the collection. We don't care which object comes first. So order doesn't matter. AB is the same as BA. For combination, order doesn't matter. AB is the same as BA. Next, let me show you the relationship between permutation and combinations. Find all three-letter permutations and combinations using letters A, B, C, D. Find all three-letter permutations and combinations using letters A, B, C, and D. So let's find out all possible three-letter permutation first. Let me first of all write down all possible three-letter permutation first. For permutation, order matters. So ABC is not the same as BCA. So ABC, that's one possible three-letter permutation. ACB, that's another one. That's another permutation. For permutation, order matters. They are different. We consider ABC and ACB, they are different. Next permutation could be BAC, BCA, CAB, CBA. Continue, we may have ABD, ADB, BAD, BDA, DAB, DBA. We may have ACD, ADC, CAD, CDA, DAC, DCA, or we may have BCD, BDC, CBD, CDB, DBC, DCB. So here we have 24. Do they have them all? Let's calculate number of permutations. We try to find a permutation of 3 letters out of total of 4 using permutation rule number 2. Permutation of 4 choose 3 is 4 factorial over 4 minus 3 factorial. 4 factorial is 24. 4 minus 3 factorial is 1 factorial. 1 factorial is 1. 24 over 1 is 24. So there are 24 permutations. Here we have 6 rows, 4 columns. There are 24 permutations. So those are all possible 3-letter permutations. Those are all possible 3-letter permutations. Now how about combination? global combination. For combination in each collection, order doesn't matter. That means ABC is the same as ACB. BAC is the same as ABC. They are all the same. As long as the objects are the same, they are exactly the same combinations. So in the first column, they are all the same as the collection A, B, C. Every permutation in the first column, if we consider they are permutation combinations, then they are all the same as the combination A, B, C. For everything in the first column, if we consider they are combinations, then they are all the same as the combination A, B, C. Then for all permutation in the second column, if I consider they are combinations, then ABD and ADB is the same. ABD and BAD is the same. Then the entire column is the same as the combination A, B, D. If you consider they are combinations, then order doesn't matter. They are all the same. They all represent the combination A, B, D. In the third column, if we consider they are combinations, then ACD is the same as ADC, the same as CAD. They are all the same. So every element in this, every permutation in the third column, they are all the same as the combination A, C, D. If we consider they are combinations, the order doesn't matter, then they are all the same as the combination A, C, D. For everything in the last column, if we consider they are combinations, then they are all the same. BCD is the same as BDC, since the order doesn't matter. Since for combination, order doesn't matter. They are all the same. They all represent a combination B, C, D. So here we can see that we have 4 different combinations. We have 4 different combinations. We have 4 different combinations. Now, do we see how permutation and combination are related? We know that for a combination of 4 objects, for a combination of 3 objects, if I switch order for these 3 objects, it makes no difference. For a combination of 3 objects, if I switch order for these 3 objects, it makes no difference. And the number of ways to switch 3 objects is 3 factorial. The number of ways to switch 3 objects is 3 factorial. So for the number of combination, we can think of combination of 4 to 3. Combination 4 to 3 is the number of permutation 4 to 3 divided by 3 factorial. We can think of this way. Combination of 4 to 3. Combination of 4 to 3, 4 objects to 3 is the same as permutation of 4 to 3. The number of permutation 4 to 3 divided by 3 factorial, because when I switch 3 objects, it makes no difference. And the number of ways to switch 3 objects is 3 factorial. When we switch 3 objects, it makes no difference. And the number of ways to switch 3 objects is 3 factorial. If I simplify this formula, numerator permutation 4 to 3 is 24. Denominator 3 factorial. 3 factorial is 3 times 2 times 1, that's 6. 24 divided by 6 is 4. So here we found 4 different combinations. Let's match what we have here. Here we found 44 combinations, and let's match what we have here. So that's the formula for combination. So keep it in mind, in general, combination C and K. Combination C and K is the same as the permutation C and K. That means we are choosing K objects out of N. Combination C choose K means we are choosing K objects out of N. So we first of all find out the number of permutation of choosing K objects out of N. Then since on each collection there are K objects, when we switch K objects in the same collection, it makes no difference. The number of ways to switch K objects is K factorial. So in general, combination Cn choose K is the same as permutation Pn choose K over K factorial. If I simplify this formula, it can be written as The numerator, Pn choose k is n factorial, the total, n factorial over m minus k factorial. The denominator k factorial can be rewritten as k factorial over 1. Then when we have a fraction divided by a fraction, we keep the top the same. Flip the bottom over. I have n factorial over m minus k factorial times 1 over k factorial. Then if I simplify, multiply together, I have c n k equal to n factorial times m minus k factorial times k factorial. That's the formula for combination c and k. Combination n choose k. We are choosing k objects out of A. We are choosing k objects out of n. So choosing k objects out of n, where an order doesn't matter. There's a number of ways of choosing k objects out of n, where an order of objects doesn't matter. Next, based on the previous example, let me show you the combination rule. Combination rule says, suppose there are n distinct objects. The number of ways to choose k objects where the order of choosing object doesn't matter. When the order of choosing objects doesn't matter. The number of ways to choose k objects is n factorial over m minus k factorial over k factorial, denoted by c and k, or some book, in many books they just write n choose k. This notation here is read n choose k. This notation is read n choose k. This is combination n choose k, but this simply read n choose k. So keep in mind that combination n choose k is n factorial m minus k factorial times k factorial. And if I say n choose k, it automatically means it's combination n choose k. So this is the same as n factorial over m minus k factorial times k factorial. For this class, we'll use this symbol, this notation for combination. For our class, we'll use this notation for combination. Next, let's look at an example here. In a basketball team of 12 players, 5 of the players are randomly chosen to form a lineup. Part A. What's the probability that the captain, David, is chosen? So keep in mind that probability is always number of favorable outcome divided by number of all possible outcome. Keep in mind that probability is always number of favorable outcome divided by number of all possible outcomes. Let's try to find out number of all possible outcomes first. Here we try to choose 5 players out of 12 to form a lineup. When we form a lineup, Order doesn't matter. We don't care who we choose first. We care who is chosen. We don't care who we choose first. Order doesn't matter. So the number of ways to choose 5 players out of 12 is combination 12 choose 5. The number of ways to choose 5 players out of 12 is 12 choose 5. That's the number of all possible outcomes. That's the denominator. Now for the numerator, the number of favorable outcomes. We try to find out in how many ways can David be chosen. In how many ways can David be chosen? We know that there are totally 12 players. There are totally 12 players. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are totally 12 players. We try to choose 5 players to form a lineup. 1, 2, 3, 4, 5. So we want to find out in how many ways can David be chosen. So in order to guarantee to choose David, let's pick David first. Once I pick David, put it here. There are 11 players left. Once I choose David, once I pick David, put it here. There are 11 players left. There are 11 players left. And we need to, in order to complete the lineup, I need to choose 4 more players. In order to complete the lineup, I need to choose four more players. Since the order doesn't matter, that's combination 11 choose 4. Since the order doesn't matter, that's combination 11 choose 4. That's the number of ways to choose 4 more players after David. That's the number of ways to choose 4 more players after David. Then simplify. The numerator combination 11 choose 4 is 11 factorial over 11 minus 4 is 7 factorial times 4 factorial. That's the numerator. In the denominator, 12 choose 5 is 12 factorial over 12 minus 5 is 7 factorial times 5 factorial. Then simplify. When I simplify, I keep numerator the same. Flip the denominator over. I get 7 factorial times 5 factorial over 12 factorial. If I simplify, I first of all cancel 7 factorial. 5 factorial divided by 4 factorial is 5. And 11 factorial, if I cancel with 12 factorial, there's a 12 left on the bottom. So the answer is 5 over 12. The chance that David is chosen is 5 over 12. Part B. What's the probability that two brothers John and Jean are not chosen at the same time? Are not chosen at the same time. What's the probability that two brothers, John and Jean, are not chosen at the same time? So denominator is always the number of all possible outcomes. Probability is number of favorable outcome divided by number of all possible outcome. Denominator is always the number of all possible outcome. For the number of all possible outcome, we are choosing 5 players out of 12 to form a lineup. Order doesn't matter. So that's combination 12 choose 5. That's the denominator, the number of all possible outcomes. Now for the numerator, the number of favorable outcome, what we want is 2 brothers, John and Jean, are not chosen at the same time. Now let's go back to the team. We have 2 brothers, John and Jean. What we want is they are not chosen at the same time. So there are 2 cases. Either John is chosen, Jean is not chosen, or Jean is chosen, John is not chosen. There are two cases. Either John is chosen, Jing is not chosen. Or Jing is chosen, John is not chosen. Or, there's one more case. Or none of them are chosen. So either we choose John, not Jing. Choose Jing, not John. Or none of them is chosen. They are not chosen at the same time. There are three cases. Either John is chosen, but not Jing. Or Jing is chosen, but not John. Or both of them are not chosen. So here we have three cases. Either John is chosen, not Jing. Jing is chosen, but not John. Or both of them are not chosen. Let's satisfy the condition that John and Jing are not chosen at the same time. So case 1. Let's consider case 1. John is chosen, but not Jing. If John is chosen, we pick John, put it here. Then we cannot choose Jing anymore. Since John is chosen, we cannot pick Jing anymore. We have 10 available players left. In order to complete the lineup, I need to choose 4 more players. In order to complete the lineup, I need to choose 4 more players out of the other 10 players. So, in the first case, if John is chosen but not Jing, we have 10 choose 4 ways to complete the lineup. In the case John is chosen but not Jing, we have 10 choose 4 ways to complete the lineup. Now case 2, that's case 1. Case 2, let me start everything over. John and Jing, let me start everything over. Case 2, Jing is chosen but not John. In order to guarantee Jing is chosen, we need to pick Jing first. If I pick Jing, put Jing here, then Jing is chosen. Since John is not chosen, we cannot pick John anymore. So John is no longer available. Then after John and Jing, there are 10 more players left. In order to complete the lineup, I need to choose 4 more players. So we choose 4 players out of a total of 10. Since John and Jing, they are not available at this moment. So we choose 4 players out of the other 10. That's combination 10 choose 4. That's second case. Third case, both John and Jing are not chosen. If John and Jing are not chosen, then they are both not available, cross them out. They are both not available, cross them out. We need to choose, in order to complete the lineup, we need to choose 5 players. We need to choose 5 players out of the other 10 players. So combination 10 choose 5. We choose 5 players out of a total of 10 players. That's the third case. That's the third case, that both John and Jing are not chosen. Then simplify. Numerator 10 choose 4 is 10 factorial over 10 minus 4 is 6 factorial times 4 factorial plus 10 factorial 6 factorial times 4 factorial plus 10 factorial 10 minus 5 is 5. I get 5 factorial times another 5 factorial. Denominator is 12 factorial over 12 minus 5 is 7 times 5 factorial. Use calculator for the answer. Use your calculator for the answer. That's part B. Part C. What's the probability? What's the probability that Davy is not chosen? The Captain Davy is not chosen. But both John and Jing are chosen. What's the probability that David is not chosen, but both John and Jing are chosen? So keep it in mind. Probability is always number of favorable outcome over number of all possible outcome. In general, we find the denominator first. Find the number of all possible outcome first. So number of all possible outcome. In how many ways can we choose 5 players out of 12? Which is 12 choose 5. That's the number of all possible outcomes. Numerator is the number of favorable outcome. What we want is David is not chosen, but both John and Jing are chosen. Let me start over. David is the captain. We have 2 brothers, John and Jing, in the team. What's the probability that David is not chosen? So we are not allowed to choose David. Cross David out. Both John and Jing are chosen. In order to guarantee John and Jing are chosen, we need to pick them first. So let's pick John and Jing first. Pick John. Pick Jing. Once I pick John and Jing, they are in the team now. Now, in order to complete the lineup, I need to choose another 3 players. Since David is not available, we pick John and Jing already. There are 9 more players left. In order to complete the lineup, I need to choose 3 more players out of 9. In order to complete the lineup, I need to choose 3 players out of 9. And that's combination. Order doesn't matter. That's combination. 9 choose 3. 9 choose 3 is 9 factorial over 9 minus 3 is 6. 6 factorial times 3 factorial. 12 choose 5 is 12 factorial over 12 minus 5 is 7 factorial times 5 factorial. Then use calculator for the rest. Get an answer. Use calculator for the rest. Next example. In a group of 8 women and 12 men, 7 people are randomly chosen to form a committee. Part A. What's the probability that the group contains only men? So keep in mind, probability is always number of favorable outcome divided by number of all possible outcome. Let's try to find the number of all possible outcome first. In how many ways can we choose 7 people out of a total of 20? So when we form a committee, order doesn't matter. We use combination. So we choose 7 people out of a total of 20. That's combination 20 choose 7. That's the number of all possible ways to choose 7 people out of 20. That's the denominator. Now for the numerator, number of favorable outcome. What's the probability that a group contains only men? That means we only choose men to form a group. In how many ways can we do that? So let me draw a rough graph here. We have 8 women. One, 2, 3, 4, 5, 6, 7, 8. Now we have 8 women. 12 men. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are totally 20 people. We try to form a committee of 7. 1, 2, 3, 4, 5, 6, 7. What's the probability that the group contains only men? If the group contains only men, we are only allowed to choose 7 people from this group. We are only allowed to choose 7 people out of 12 men. We are only allowed to choose 7 people out of 12 men. The number of ways to choose 7 men out of 12 is 12 choose 7. The number of ways to choose 7 men out of 12 is 12 choose 7. That's the number of favorable outcome. Then simplify. We have 12 factorial, 12 minus 7 is 5, times 7 factorial. 20 factorial, 20 minus 7 is 13 factorial, and times 7 factorial. When we divide, we keep the top the same. 5 factorial times 7 factorial minus the times the reciprocal. 13 factorial times 13 factorial times 7 factorial over 20 factorial. I can cancel 7 factorial here. Use calculator for the rest. Use calculator for the rest. We can get an answer. Part B. What's the probability that a man, Tom, and 2 sisters Lily and Lucy are chosen at the same time. What's the probability that a man, Tom, and 2 sisters, Lily and Lucy, are chosen at the same time? So keep it in mind, probability is always number of favorable outcome divided by number of all possible outcome. For the denominator, all possible outcome, we are choosing 7 people out of 20. It's 20 to 7. For the numerator, number of favorable outcome, what we want is Tom and 2 sisters, Lily, Lucy, they are all chosen at the same time. So we have a man, Tom. Suppose this guy is Tom. 2 sisters, Lily and Lucy. We're looking for the chance that they are all chosen at the same time. So in order to guarantee they are chosen, let's pick them first. So Tom is chosen. Lily is chosen. Lucy is chosen. If they are all chosen, what's left is there are totally 20 people. If they are all chosen, if Lily, Lucy, and Tom are chosen, we have 17 people left. If 3 of them are chosen, we have 17 people left. And in order to form a committee, we need 7 people. That means we need to pick 4 more people. Since Tom, Lily, and Lucy are chosen, we need to pick 4 more people to form a committee. So we need to choose 4 more people out of a total of 17. So in order to complete the committee, to form a committee, we need to choose 4 more people out of 17. Since the order doesn't matter, it's combination. 17 choose 4. Then simplify, we have 17 factorial, 17 minus 4 is 13 factorial times 4 factorial. Denominator 20 factorial, 20 minus 7 is 13 factorial times 7 factorial. Use your calculator for the rest. Use calculator to get the answer. Part C. What's the probability that the committee contains 2 women and 5 men? What's the probability that the committee contains 2 men, 2 women, and 5 men? What's the probability that a committee contains 2 women and 5 men? So probability is always number of favorable outcome divided by number of all possible outcome. For the number of all possible outcome, we are choosing 7 people out of 20. That's 20 to 7. For the numerator, we want to have number of favorable outcome. Number of favorable outcome. What we want to get is 2 women and 5 men. Look at the picture here. 2 women and 5 men. So let me start everything over. Totally, there are 8 women, 12 men. We try to form a committee with 2 women and 5 men. So 2 women, 5 men. In order to pick 2 women, we pick 2 women out of A. That's A choose 2. That's the number of ways to choose 2 women out of A. Then in order to choose 5 men out of 12, that's 12 choose 5. Since we have this many ways to choose 2 women out of A, and we have this many ways to choose 5 men out of 12, by combination, by counting principle, we have this times this many ways to choose 2 women and 5 men. Since there are this many ways to choose 2 women and this many ways to choose 5 men, by counting principle, together they are this times this many ways to choose both 2 men and 5 women. So the number of favorable outcome is A choose 2 times 12 choose 5. By counting principle, we multiply them out. Counting principle says if there are n ways to do one task, n ways to do a second task, then together there are n times m ways to do both tasks. Here we have this many ways to choose 2 women and this many ways to choose 5 men. Together we have this times this many ways to choose 2 women and 5 men. Then that's number of favorable outcome. Simplify. We have A factorial, A minus 2 is 6 factorial times 2 factorial times 12 factorial, 12 minus 4 is 7 factorial times 5 factorial. 20 to 7, 20 factorial, 20 minus 7 is 13 factorial times 7 factorial. Use calculator, you can get an answer. Use calculator for the answer. Part D. What's the probability? What's the probability that there are more women than men in the committee? Part D. What's the probability that there are more women than men in the committee? So probability is always number of favorable outcome divided by number of all possible outcome. Denominator is 20 to 7. We're choosing 7 people out of 20. That's the denominator, number of all possible outcome. Numerator, number of favorable outcome. What we want is more women than men. If we choose more women than men, there are 7 people, means either 4 women, 3 men, or 5 women, 2 men, or 6 women, 1 man, or 7 women, no men. We have 4 cases. The number of ways to choose 4 women, 3 men is A choose 4 times 12 choose 3. That's the number of ways to choose 4 women out of 8, 3 men out of 12. Case 2. The number of ways to choose 5 women out of 8 is A choose 5. The number of ways to choose 2 men out of 12 is 12 choose 2. Next case. 6 women, 1 man. The number of ways to choose 6 women is A choose 6. The number of ways to choose 1 man is 12 choose 1. Last case. 7 women. The number of ways to choose 7 women out of 8 is A choose 7. Then that's a numerator. That's a number of viewable outcome. A choose 4 times 12 choose 3 plus A choose 5 times 12 choose 2 plus A choose 6 times 12 choose 1 plus A choose 7. Then use your calculator. When you use your calculator, be very, very careful. 20 choose 7. It doesn't mean 20 divided by 7. A very, very common mistake. 20 choose 7 doesn't mean 20 divided by 7. That's a very, very common mistake. Be very careful. Combination 20 choose 7 is 20 factorial. 20 minus 7 is 13 factorial times 7 factorial. That's how we solve combination. 20 choose 7 doesn't mean 20 divided by 7. Be very, very careful. That's a very, very common mistake. Be very, very careful here. So here, use your calculator for the answer. Next example. When a hand of 5 cards are dealt from a standard deck of 52 cards, find each of the following probabilities. Part A. What's the probability of getting exactly 3 kings? What's the probability of getting exactly 3 kings? So, that's the standard deck of 52 cards. There are 4 suits: club, spade, heart, and diamond. And there are 13 different ranks or 13 different kinds. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, and King. Jack, Queen, and King are called face cards. We have 4 suits times 13 different ranks. There are totally 52 cards. That's the standard deck of 52 cards. What's the probability of getting exactly 3 kings? So for probability, keep it in mind, it's always number of favorable outcome divided by number of all possible outcome. So number of all possible outcome is, there are totally 52 cards. We choose 5 cards randomly. The number of ways to choose 5 cards out of 52 is 52 choose 5. And we draw 5 cards. The order doesn't matter. We don't care which card we get first. We care what we have in our hand. We don't care which card is coming first. We care what we have in our hand. We don't care which card comes first. So order doesn't matter. We use combination. 52 choose 5. We are choosing 5 cards out of total of 52. That's the denominator, number of all possible outcome. Numerator, number of favorable outcome. What we want is the probability of getting exactly 3 kings. Exactly 3 kings. So the number of ways to choose 3 kings is 4 choose 3. There are 4 kings. The number of ways to choose 3 kings out of 4 is combination 4 choose 3. That's the number of ways to choose 3 kings out of a total of 4 kings. Then since we need to have 5 cards, since we pick 5 cards, 3 of them are kings, we need to have 2 more cards. Since we cannot pick any other king anymore, so we can pick 2 more cards out of the rest. Other than these kings, we have 48 cards. Other than kings, we have 12 rings times 4 different suits. 12 times 4, we have 48 other cards. So other than kings, we have 48 other cards. We need to choose 2 more cards. So choose 2 more cards out of 48. Then we have 4 choose 3 is 4 factorial, 4 minus 3 is 1 factorial times 3 factorial, 48 factorial, 46 factorial times 2 factorial over 52 factorial, 52 minus 5 is 47 factorial times 5 factorial. Use calculator for the rest. Part B. What's the probability of getting two clubs and three hearts? What's the probability of getting two clubs and three hearts? Denominator is always the number of all possible outcomes, which is 52 choose 5. Numerator, what's the chance of getting two clubs, three hearts? There are totally 13 clubs, 13 hearts. We want to have two clubs and three hearts. Two clubs and three hearts. For the number of way of choosing two clubs is 13 choose 2. The number of way of choosing two clubs out of 13 is 13 choose 2. Combination 13 choose 2. The number of ways to choose three hearts out of 13 is combination 13 choose 3. Then use calculator for the rest. Part C. What's the probability of getting all hearts? Part C. What's the probability of getting all hearts? All hearts. 1, 2, 3, 4, 5. All hearts. What's the probability of getting all hearts? So probability is always number of favorable outcome divided by number of all possible outcome. Number of all possible outcomes is 52 choose 5. We are choosing 5 cards out of 52. What's the chance of getting all hearts? That means we are choosing 5 hearts out of 13 hearts here. We are choosing 5 hearts out of 13 hearts. The number of ways of choosing 5 hearts out of 13 is combination 13 choose 5. Then use calculator for the rest. Next. What's the probability of getting four of a kind? What's the probability of getting four of a kind? Four of a kind, that means, four of a kind, it means 4 cards have the same type. 4 cards has the same ring. The other card has different ring. 4 of a kind, that means 4 cards have the same ring. The other card has different ring. 4 cards have the same ring. The other card may have different ring. That's what 4 of a kind means. So probability is always number of favorable outcome divided by number of all possible outcome. Number of all possible outcomes is 52 choose 5. We are choosing 5 cards out of 52. That's the number of all possible outcome. For a number of favorable outcome, what we want is getting 4 of a kind. That means 4 cards of the same ring. The other card have different rank. Let's take care of these 4 cards first. These 4 cards, it could be 4 aces, 4 twos, 4 threes, 4 fours, 4 fives, and so on. It could be one of these 13 rank. These 4 kinds, these four cards of the same kind, it could be one of these 13 ranks. So let's 13, choose 1. It could be one out of these 13 ranks. Then once I pick the rank, for example, if I pick 6, as a rank, there are 2 6, there are 4 6. It could be 6 of club, 6 of spade, 6 of heart, 6 of diamond. Once I pick the rank, there are 4 6. Then I pick them all. I choose them all. 1, 2, 3, 4, 5. I pick them all. I put all these 6 cards here. So that's 4, choose 4. We are choosing 4 cards out of these 4 cards, out of a total of 4. Then for the single card itself, for the single card here, we must pick different rank. Since we use 1 rank already, we must pick different rank. So in order to pick a different rank, let's 12 choose 1, since we cannot pick 6 anymore. Assuming we pick 6 for this 4 of a kind, we cannot pick 6 anymore. So there are 12 other ranks left. We choose 1 different rank out of 12. Then, for example, if I pick 9, if I pick 9 as my second for the single card, I pick 9. If I pick 9, same thing. There are 4 different suits. For number 9, there are 4 different suits. Could be 9 of spade, 9 of heart, 9 of diamond. Then we choose 1 of these 4 cards, put it here. Say we pick 9 of spade. The number of ways to choose 1 card out of 4 is 4 choose 1. Then use calculator, we can get an answer. Part E. What's the probability of getting 2 pairs? What's the probability of getting 2 pairs? 2 pair looks like this. 2 pair means 2 cards have the same rank. Another 2 card has a different rank. A single card has another different rank. So 2 cards have the same rank. Another 2 cards have the same rank. Another card have another rank. So that's called two pairs. When we're getting 5 cards, that's called 2 pairs. Probability is always number of favorable outcome divided by number of all possible outcome. The denominator here is 52, choose 5, since we are choosing 5 cards out of 52. For the numerator, how do we get 2 pairs? Let's take care of these 2 pairs first. For these 2 pairs, we must choose 2 different ranks out of 13. For these 2 pairs, we must choose 2 different ranks out of 13. For example, if I pick 2 and 5, pick two different ranks out of 13. If I pick 2 and 5, that's 13, choose 2. The number of ways to choose 2 ranks out of 13 is 13, choose 2. Then once I pick 2 ranks, 2 of 2 and 5, for number 2, we have 4 different suits. We have 2 of club, 2 of spade, 2 of heart, and 2 of diamond. For number 5, we also have 4 cards. We have 5 of club, 5 of spade, 5 of heart, 5 of diamond. In order to form two pairs, I choose 2 twos out of 4. I choose 2 twos out of 4. For example, I choose club of 2 and diamond of 2. Or I choose club of 5 and heart of 5. That's 2 pairs. It's 2 pairs. So in order to get 2 twos out of 4, that's 4 choose 2. In order to get 2 fives out of 4, because there are 4 fives here. 1, 2, 3, 4. We choose 2 of them. That's 4 choose 2. So this 4 choose 2 means we are choosing 2 twos out of 4. This 4 choose 2 means we're choosing 2 fives. We're choosing 2 fives out of 4. We're choosing 2 fives out of 4. Then take care of this single card here. This single card must have different rank than the first 2 pairs. This single card must have a different rank than these 2 pairs. For the single card, since I picked 2 and 5 already, I pick different rank. Since I cannot pick 2 and 5, there are 11 different ranks. I pick 1 rank out of 11. So pick a rank. Pick a rank of the cards other than 2 and 5. We have 11 choice. So pick different one. Say I pick A. For example, I pick A. Then I have 4 A's. A of club, A of spade, A of heart, A of diamond. So choose 1 different rank out of 11. Then for the last card, I choose 1 A out of 4. There are 4 A's. I choose 1 number A out of 4. For example, I pick A, diamond of A. That's 4 choose 1. We're choosing 1 out of 4 here. 4 choose 1. Then use calculator for the answer. Next example, a hand of 5 cards is dealt to each of the 2 players from a standard deck of 52 cards. First question, what's the probability that each player receives a pair of A's? So keep in mind that probability is always number of favorable outcome divided by number of all possible outcome. Let's take care of the denominator first. How do we find number of all possible outcomes? So from a standard deck of 52 cards, a hand of 5 cards is dealt to each of 2 players. So there are 2 players. Each of them will receive 5 cards. 1, 2, 3, 4, 5. That's first player. The second player. 1, 2, 3, 4, 5. When they are choose cards, order doesn't matter. We don't care which card he picked first. We care what he picked. So order doesn't matter. Order of getting cards doesn't matter. We should use combination. So 2 players. Each player gets 5 cards out of total of 52. There are 2 players. Each player gets 5 cards out of 52. So let's let the first player pick 5 cards first. When the first player make choice, he can choose 5 cards of the number of ways to choose 5 cards is 52 choose 5. That's the number of ways to choosing 5 cards out of 52. That's the first player. After first player make choice, there are how many cards left? There are totally 52 cards. After the first player make choice, he pick 5 cards. What's left is 47 cards for the second player. There are totally 52 cards. After the first player pick 5 cards, there are 47 cards left for the second player. So second player also choose 5 cards, but he is chosen from what's left. What's left is 47 cards. He chose 5 cards out of 47. That's the number of all possible outcomes. First player pick 5 cards out of 52. Second player pick 5 cards out of what's left. That's the denominator, number of all possible outcomes. Numerator. What's the probability that each player receive a pair of aces? What's the probability that each player receive a pair of aces? We know that there are 4 aces. Ace of club, ace of spade, ace of heart, ace of diamond. There are 4 aces. What's the probability that each player get a pair of aces? What's the probability that each player get a pair of aces? So let's make choice for the aces. Let's let the first player pick the cards first. We have 4 aces and 48 other cards. Then the first player make choice first. First player won 2 aces, then 3 other cards. First player won 2 aces and 3 other cards. So when he makes choice, he chooses 2 aces out of 4. When the first player makes choice, he chooses 2 aces out of 4. Then for the other cards, he picks 3 cards out of 48. He picks 3 cards from here. He picks 3 cards from here out of 48. So he picks 3 cards out of 48. That's the number of ways of choosing 3 cards out of 48. That's the first player. That's how the first player makes choice. On the second player, since there's only 4 aces, first player pick 2. First player pick 2. For the second player, what's left is the other 2 aces. For the second player, there's no choice. Whatever left, he put it here. For the second player, he has no choice. Whatever left, he put it here. So that's 2 choose 2. For the second player, he chooses 2 aces out of 2. Because after the first player makes choice, there's only 2 aces left. The second player chooses the rest. Now, for the other cards, there are originally 48 other cards. But the first player already picked 3. First player picked 3. What's left is 48, 45. Right now we have 45 cards left. Because first player picked 3 cards out of 48 already. First player already picked 3 cards from this set. So what's left is 45 other cards. Second player needs to pick 3 other cards. Second player needs to pick 3 other cards. So he picks 3 cards out of what's left here. That's 45, choose 3. He chose 3 cards out of what's left here. What's left is 43. What's left is 45 because first player picks 3 cards out of 48. What's left is 45 cards. Second player chooses what's left here. What's left is 45. He picks 3 cards from what's left. Then for the rest, use your calculator for the rest. Use your calculator for the rest. Part B. What's the probability that one player receives all hearts? One of the players receive all hearts. And another player receives all diamonds. What's the probability that one of the players receives all hearts and another player receives all diamonds? So keep it in mind, probability is always number of favorable outcome divided by number of all possible outcome. What's the probability that denominator? What's the probability that in how many ways can each player get 5 cards out of 52? So there are totally 52 cards. First player pick 5 cards out of 52. What's left is 47. Second player choose 5 cards from what's left. What's left is 47 cards. Second player pick 5 cards out of 47. That's the denominator, number of all possible outcomes. Now for the numerator, number of favorable outcomes, what we want is one player receives all hearts, another player receives all diamonds. So here there are 2 cases. Either first player receive all hearts, second player receive all diamonds, or first player receive all diamonds, second player receive all hearts. So there are 2 different cases. Either first player receive all hearts, second player receive all diamonds, or first player receive all diamonds, second player receive all hearts. There are 2 different cases. Let's calculate the chance here. First player receive all hearts. First player receive all hearts. First player needs to choose 5 hearts out of 13. If first player receives all 5 hearts, he needs to choose 5 hearts out of 13. If first player receives all hearts, he chooses 5 hearts out of 13. That's 13 choose 5. Now for the second player, if the second player receives 5 diamonds, we know that there are totally 13 diamonds. The number of ways to choose 5 diamonds out of 13 is 13 choose 5. And there are 2 different cases. It could be either first player receive all 5 hearts, second player receive all 5 diamonds, or first player receive all 5 diamonds, second player receive all 5 hearts. So multiply by 2. Then use your calculator for the answer. Part C. What's the probability that none of the players receive any club? What's the probability that none of the players receive any clubs? So probability is always number of favorable outcome divided by number of all possible outcome. Number of all possible outcome is 52 choose 5 times 47 choose 5. For a number of favorable outcome, what we want is none of the players receive any clubs. So club is not available for both players. Cross them out. Club is not available for both players. Then we let 2 players make a choice. 1, 2, 3, 4, 5. That's first player. That's second player. 1, 2, 3, 4, 5. So we let first player make a choice first. When first player makes a choice, he cannot choose any clubs. So he can choose spade, heart, or diamond. There are 39 available cards. He has 39 choice. Since he cannot pick clubs, he has 39 choice. So there are 39 choice for the first player. He picked 5 cards out of 39. After first player picked 5 cards, for the second player, what's left is 34 cards. There are totally 39 cards. After first player make a choice, pick 5 cards. What's left is 34 cards. Then the second player choose 5 cards out of 34. That's the number of ways of getting no clubs. That's 39 choose 5 times 34 choose 5. Then use your calculator for the rest.